So when you first log in, you'll be presented with this home page and it'll say welcome to your organization's dashboard. There's a table here with a link to your recent projects. If you haven't modeled any yet, we have preset a few sample projects onto PK, so you can have a look at how we've structured a few common packaging types and projects in PK. Alternatively, if you want to jump straight into modeling your own project, you can do so here by clicking New Project. And it asks you to select either a packaging or a product project. So once you hit Next, it asks you a few questions about your project. And the first one is to give the project a name. Select the privacy. So this is just whether you want to be able to share this project with other people in your organization, specify 1 or 2 other people, or keep it private. And then it asks you to highlight the default country where most processes will be carried out. So this just means, as you know, we've regionalized all the processes across 54 different regions. If all of your processes take place in Australia, or most of them take place in Australia, you can specify that here. And unless you tell PK otherwise, it will always assume that whatever country is selected here is the region in which the process is carried out. So here it asks where will all of the processes be carried out. And this lets you define a few regions, so you don't have to see this big long drop list of countries each time. You can just specify that, you know, they're all happening in, say, these countries. So we'll save that. And the next important thing to do is specify your project scope. So this is sort of like your system boundary. Here is where you define which inputs or which processes you would like to include and which you would like to exclude from your study. And PK is a dynamic tool. So whatever you have ticked here, PK will evolve to show the input fields for that. If you want to exclude filling, because you know the compostable bag that you want to model has the same filling process as the non-compostable bag, you can choose to exclude that here. And so no fillings sections or boxes will be displayed by PK. But say you wanted to include some transport to wholesale, this is where you might want to model the packaging efficiency. You could tick that here and that will bring up the wholesale section. So I'll stick with a simple retail package, ignoring products for now. But if you did click on this one, you can see that it automatically updates to include a few more life cycle stages and a few more packaging levels. And then the final option is full package and product. And this lets you account for things like product loss or product mass during transport, as well as the full impacts of the product itself. So what goes in the compostable bag. Okay, so hitting next down here, PK will automatically save your selections for you. So you don't have to hit save, you can just hit next. But I know I sometimes like having that added level of security. If you've spent a long time modeling something, it's you like to be able to know that when you hit save, it's all going to be there. So the next step is to start modeling your scenarios. So we'll click Add New Scenario here. And this is where we would model the compostable bag. And the other scenario that, let's say in this packaging project, there's 2 scenarios. There's the compostable and the non-compostable. There is a section here, select package to copy. I haven't modeled any scenarios yet, so there's no scenarios available in the drop down. But once I have started modeling scenarios, I can copy existing scenarios here and just change one or two aspects of it. And it means that you don't have to be modeling entire scenarios from start to finish each time. You can just copy and then make the changes required. Okay. So thinking about a compostable bag, maybe it only has one component, it's the bag itself. I'm picturing in my head a compostable produce bag, like those ones that you get at the supermarket. But if you were modeling, say, a milk bottle, you'd think about, what are the different components of this milk bottle? Does it have the body of the bottle, the lid, the label? Does it come in a shipper? This is where you start building out the specific components of each scenario. So I'll click Add Component Detail here and give it a name. This is just the bag. And we're just looking at the retail units for now. We're not thinking about how many bags come in a shipper and how many shippers fit on a pallet. If you did want to model that, you would select the specific packaging level of that component here. So coming down, this is where you select the material details. So if you wanted to build a custom or a composite material, you could do so by ticking this box and going to the Add Custom Material section here. But in this case, I'm assuming this compostable bag, let's just make it PLA. So we do have PLA here. And it gives you a warning that this material can't have any recycled content in it. PLA would be composted, not recycled. So the recycled content section automatically is removed when we select PLA. So the weight, I would imagine it would be quite light. Ideally, if you've got a little scale, a little scale, you'd weigh them and have primary data in there, but I trust Tim. Okay, and then we come down to transportation to converter. So this is the distance between where the resin or the raw material is sourced to where it gets converted into a bag. So there's a few different options here. If you know the exact distance, you can select the transport mode, whether it's air, shipping, rail freight, various different truck options. You can select the transport mode and then manually input the distance here. Otherwise, if you know that the resin comes from Singapore, you can set the origin, and the destination is it comes into the port of Melbourne. Via international shipping, add transport leg. And through our API with C-Rates, it automatically has the shipping distance between Singapore and Melbourne input in that model for you. So that's just that first transport leg. I missed, maybe here the resin comes from the resin factory is right next to the port. If it had to be transported a little bit, I should have put that in beforehand. But maybe it goes from the Port of Melbourne to a factory in Dandenong South via average lorry or truck, add transport leg, and it automatically calculates that truck distance for you. Okay, so now our PLA resin has arrived at our factory in Dandenong South, and this is where we're converting it from its raw resin into a bag. So we've got a few different options here. So PK automatically has a few recommended conversions based on the material that you've input here. If you don't see the conversion process that you need, you can untick that and it gives the entire list of conversion processes that we have in our database. Okay, so here that you can see this is another second example of it automatically assuming the where the process takes place because we selected Australia in the settings. It assumes that that the conversion takes place in Australia. I'll just go up here. It also assumed that the resin was sourced from Australia. I'll just change that to Singapore because I've said in our transport that it comes from Singapore. Okay, so we'll add that conversion and there's a summary of that there and hit save. So this is our compostable bag, just the materials and conversion. If we hit next, you'll see a summary of the transport to converter as well as the conversion process. So if we hit next again, we've said that there's a transport to wholesale. So let's just say there's a few different wholesale factories all around Victoria that it goes to. So we're just going to assume that it's an average transport distance of, say, 140 kilometers, and we'll add that manual distance there. Okay. The next and final life cycle stage that we're modeling here is end of life. So there's a few different sections here. There's end of life and there's reuse. Reuse is could be beneficial here. Say we wanted to compare the compostable bag with one of those reusable fabric bags. We'd build out that scenario and then for the reusable scenario, we'd add in some reuse here. So I'll just show you how to do that. Select the component. And you can either give it a reuse rate, which would be a rate anywhere between 0% and 100%, or you could give it a number of trips. Say you'd say the average consumer uses that reusable fabric bag about 4 times before they accidentally leave it in their shopping trolley one day and it gets lost and they need to buy a new one. So we've got our reusable fabric produce bag here. Maybe the manufacturer says it's got 400 uses in its lifetime before it will eventually break. But we know realistically consumers, lose things and forget things. And so maybe let's just give it a 10 number of trips to be conservative. So in this case, the filler is sort of like the customer. So they take it to the supermarket and then they bring it home. And that supermarket might only be a 10-minute bicycle trip or to a 5-kilometer bicycle trip. So we'll add that in. And once they take it home, there is a reuse process. So there's a washing process. So we'll select water here and 0.1 milliliters of water is used to wash each reusable bag. So that's where you add all of that in into the reuse process. So we'll hit save there. And it summarizes the reuse component of that bag. So the other section in end of life is the end of life itself. So that bag has 10 trips. What happens on the 11th time? it's a retail unit, so it's classified as consumer end of life because it's the consumer takes it home from the supermarket, and the consumer is the one that throws it away, not the supermarket itself. Because it's PLA in Australia, we have assumed that 99% of it goes to landfill. There's not a huge amount of data available on commercial composting of PLA in Australia yet. But, you know, say you wanted to be a little bit more optimistic, and assume that 50% goes to landfill and the rest of the consumers who use it are good and they home compost it. You can manually override the end of life dates that we have for each material there. As long as they add up to 100%, it will save. So if I try to say that that 50% goes to landfill and 60% goes to home composting, it'll give you this warning error message. That is how you model, very briefly, a very simple retail package only, considering materials, conversion, some reuse, and some end of life. So this is our compostable bag, although we're directing it to pyrolysis in this case. Say we want to compare that to a non-compostable option. If we hit next, it says, do you want to add another package scenario? Yes, I do. I want to compare that to a non-compostable. So I click on this three little dots here and click copy. It'll automatically give it a new scenario named compostable bag _ copy. Let's just change that to non-compostable bag. Save. So this is an exact copy of the other scenario. I can move them around. If I want to have the non-compostable one first, I can drag them here. As Gab mentioned as well, you can upload images to PK. If you wanted to, you know, have a visual representation of what each looks like, that would be summarized here. But now I need to make my changes. So I double click on this scenario to edit it. It's just giving me this error message for the reporting. We have a maximum of 15 characters for the report. Compost. Okay, so all I need to do for here is jump into my bag and change the material from PLA to, I guess the non-compostable would be LDPE. And maybe it's a little bit lighter. And maybe it's made out of a little bit of recycled content as well. Other than that, everything else we'll say stays exactly the same, except for end of life, which so it's got new rates for LDPE. Oh no, it's copied that 100% of it goes to pyrolysis. Let's say in this case that doesn't occur, they all get sent to landfill. Like that. And then maybe these ones don't get reused as much. Maybe these only get reused 10% of the time. Actually, well, let's just remove reuse for now. I've shown you how to model it, so if you did want to model reuse, you can do so. But because this is we're going back to the compostable, non-compostable bag scenario, I don't want to confuse everyone. Okay, so now we've got our two scenarios that have been modeled. We hit next. No, we don't want to model another packaging scenario. Here's where we get to our chart at a glance modeling. So I'm going to select my two scenarios. I want to see I'll show you both. We'll start with a bar chart. So you can show a comparison by a number of different options here. And I would encourage you to have a play around to see what they look like. Packaging level, well, they're both single retail units, so that's not going to show us much here. I'll keep it comparison by life cycle stage for now. And I want to see the carbon footprint of each. So I'll generate that. And PK's thousands of background calculations, so it can take a few seconds. And here we go. Straight away, we can see the non-cost compostable bag has a lower carbon footprint. And the reason for that, I would imagine we can see straight away that it's at the material stage here. I would say it's because we've made it a little bit lighter than the compostable bag. Alternatively, if we wanted to see a snapshot based on a few different impact categories, yeah, we can see the compostable bag has a higher water use and land use as well. So there we go. There's our chart at a glance reporting.